Yes. All right. So this is the Mod B review. I will be making 2 videos to go with this review. And the first video will cover up through question number 11. The next video will just cover 12 and 13. I will not be doing every single question on this. The expectation is that you use this to support you in your work. I start some of the questions, and then you finish them, or you work out the ones I haven't done. So this first 6 questions here is just describing the transformation based off of what you see. So in this first one, we have a -1 inside the parentheses. That moves us to the right one. And the +2 on the end moves us up 2. So those are our 2 different transformations. In number 2, we've been stretched. That's what that 2 out front does. So stretched by 2, and then right 1. In number 5, we have a reflection. That's what the negative sign does. We have a compression. That's the 3/4. So compressed by 3/4. And then we're moving to the left 6. Okay, so in number 7, the first thing we want you to do, identify the parent function. So this one is quadratic, and I know it's quadratic because of the exponent of a 2. Down here where it says transformation, we're just asking for exactly kind of what we just did up in 1 through 6, and that is, tell me what the negative sign, the 2, the 1, and this one all do to the graph. So we have a reflection. We have a stretch. That stretch is the 2 out front. We are moving to the left one. That's this. This is the left one right here, the +1 inside the parentheses. And then we're moving down 1. So we've got quite a bit going on here. So stretch by 2, left 1, and down 1. So that's what we're looking for on that. All right, so let's graph this. We're going to begin with the parent functions. The quadratic, which has key points of 0, 0, 1, 1, -1, -1, 2, 4, and -2, -4. All right, now this graph, excuse me, this graph doesn't fit super well. We actually probably should have done to 8, but that's okay. To stretch by 2 and reflect, so I'm going to take care of both of these parts at once. I'm going to multiply my heights by -2. So I'm going to start with these 2 dots right up here. They currently have a height of 4. When I multiply them by -2, their new height is -8. So we're down here somewhere. Okay. We'll adjust those in a moment. And now we'll move to these 2 dots that currently have a height of 1. When I multiply them by -2, the new height is -2. And zooming in here. This dot here in the middle is at a height of 0. When I multiply that by -2, height stays at 0. All right, now we're going to move left 1 and down 1. So we'll go to purple here. Left 1, down 1, left 1, down 1, left 1, down 1, down 1, left 1, down 1. So here's our graph. There we are. Okay, sliding over. Here we have a radical graph, And I know that because of the radical sign or the square root sign. Transformations out front, we have a 1/2. That's going to compress by 1/2. So compress by 1/2. We're moving to the right 3 and up 2. Okay, so let's put those parent function dots on there. 0, 0, 1, 1, and 4, 2. Okay, so to compress by 1/2 means to multiply the heights by 1/2. So this dot on the end has a height of 2. When I multiply that by 1/2, it moves it to a height of 1. Sliding in, this dot has a height of 1. When I multiply that by 1/2, it drops it down to 1/2. And 0 stays at 0. And now we're going to move these right 3 and up 2. So right 3, up 2. Right 3, up 2. Right 3 up 2 ends up off the graph. And there's our radical graph. Okay. Rewatch these and pause them as necessary so that you can get them. Maybe you watch it all the way through once, and then you try it on your own, then you rewatch it. Let's keep going. We've got 2 more. Here our parent function is rational. The transformation, so we have a right 1 and an up 3. Okay, so in a rational graph, I'm going to start with these asymptotes at the zeros. Our key points start at 1, 1 and -1, -1. We don't have any stretching or reflecting. We're just sliding it right 1 and up 3. Well, not only do we slide the key points, we also slide the asymptotes right 1 and up 1, 2, 3. So my new asymptotes end up at 1 and at 3. My key points started right at 1, 1 and -1, -1, and they moved right 1 and up 3, right? So right 1, up 3, and that's where we land, and then we draw the graph. Sorry about switching colors on you there, but had to use my snipping tool to move the asymptote, so it moved the dots with it as well. Okay. And finally, we have this cubic graph. Key points for a cubic are 0, 0, 1, 1, -1, -1. And then by 2, we're up here at 8, and at -2, we're down here at -8. All right. Transformations. So we have been reflected, and then we've been moved to the right 1 and down 2. Right 1, down 2. Okay. So we'll start with the reflection. So this dot, let me make that a little smaller. This dot up here at 8 is going to drop down to -8. This dot at -8, right? So this dot down here is going to jump up to +8. All right, so the dot at a height of 1 is going to go to -1, 0 is going to stay at 0, and the dot at -1 is going to jump up to a height of 1. Okay, now we're going to move everything right 1 and down 2. So we're going to go right 1 down 2, right 1 down 2, right 1 down 2, right 1 down 2. We're still off the graph, and now we're way off the graph. So this point here is our center that was at 0, 0. It is the point at which we are symmetric about. So this is symmetric over the point 1, -2. Okay. Now, writing an equation from a picture. We should start with what is this, right? So this is absolute value. We didn't have that part on the review, but I'm going to add it. So it is an absolute value graph. Identifying some movements, this came from 0, 0, 0, so it went left 2, left 2, and then down 3. Okay. So left 2, down 3, so that's going to give me y equals, I leave a little space, x plus 2, and then minus 3. So there's my left 2 and my down 3. To figure out whether it's been stretched or not, I take a look. I go 1 to the right. Remember, this scales by 2s, so this gap right here represents 1. Then I'm going vertically. How far do I need to go before I hit my graph? So here, I've got to go up 1, 2. Up 1, 2. That means there's a 2 in the front of my equation. That means it's been stretched by 2. All right, absolute value graphs have, first of all, these should have arrows. The domain is negative infinity to infinity. The range is low to high, so negative 3 to infinity. And notice I made a bracket at negative 3 because it's not an asymptote, it's not an open circle, and it's not infinity. All right, interval of increase. Well, this graph is increasing. Let me grab a hiker friend here. That's a terrible person, but so we're increasing here, starting at the bottom, and it's increasing. Remember, we use x values for interval of increase, so it's increasing from x equals negative 2 onward. So an interval of increase will be negative 2 to infinity. The decrease comes on the other side over here, so we're always decreasing until we get to negative 2. So because it's happening on the left, we say negative infinity up to negative 2. The x-intercepts are, that's not very nice. It looks like it's 1/2, comma 0, or negative 1/2, excuse me. That's this one right here, negative 1/2. And then over here we have negative 3.5, so negative 3.5, comma 0. The y-intercept is 0, 1. And there we go. Okay, let's keep going. Again, rewatch any of these that you need. This notation stands for the inverse. So that's just switch x and y. So negative 2, 4 becomes 4, negative 2. 4, 7 becomes 7, 4. 0, 11 becomes 11, 0. Algebraic inverse, again, we're just switching x and y. So this is x equals 15, y minus 1. And now we solve for the new y. So I add 1. X plus 1 equals 15y. Divide by 15. So y equals x plus 1 over 15. Swap x and y. Solve for the new y. Subtract 7. Now x minus 7 equals 1/3 y. To clear the 1/3, we multiply both sides by 3. And I'm going to distribute that 3. So it becomes 3x minus 21 equals y. Okay. X equals the y minus 2 squared. So I'm going to take the square root of both sides. So the square root of x equals y minus 2, adding 2. And this one, it's important that you do not put the 2 underneath the radical sign. This 2, I don't know what I just did there. This 2 is outside of the radical sign. The only thing underneath the radical sign, underneath the square root sign, is the x, so the plus 2 is outside. It's a very important part of that. Okay, one more. So now we have x equals the square root of y minus 4. To get rid of that, we square both sides. So we have x squared equals y minus 4. We add 4. So then x squared plus 4 equals y. Okay. Last one in this video, graph the inverse. So we're going to just kind of make these points a little bit bigger because they should be right on the line. So here we have 1, 2, 3, 4, 5 points to reflect. All right. The 2 points on the line will stay on the line. And then we need to kind of come up with our ordered pairs of the other ones. So -1, 2, 3, 4. So -1, -4 will move to -4, -1. All right, so that's -4, -1. Let me slide this over, I think is going to be a better spot for it. All right, let's go 1, 2.5, down 1, 2. So 2.5 down 2 is going to go to -2 and up 2.5. Okay. On the exam, they're nicer points than that. Last one is 1, 2, 3, 4, 1, 2. So 4, 2 is going to go to 2, 4, 1, 2, 1, 2, 3, 4. And then I draw that in. And put the arrows on the end here, and there's our inverse. All right. So in the next video, we'll do the other parts, but I want to cover those in class first, and I wanted to get this video posted.